Welcome all of you. Continuing with our chapter that is matter around us pure? And in the previous video we discussed uh, pure substances and impure substances and mixtures, homogeneous mixtures. The properties of homogeneous mixtures was the last thing that we discussed in the previous video. As you can see, matter around us exists as pure substances and impure substances or mixtures. Uh, as you can see, pure substances can be either elements or compounds. Impure substances are also known as mixtures. Mixtures are then categorized as homogeneous mixtures and heterogeneous mixtures. Then we have solutions, which are a subtype of homogeneous mixtures. Rather, all solutions are homogeneous mixtures. Then we have heterogeneous mixtures having suspensions and colloids. We have to discuss all these one by one. So let us try to understand. As I told you that most of the things that we see in our surroundings are mixtures. Like we have air is a mixture of gases. Milk that we see constitutes water, proteins, carbohydrates and fats. Soil is also a mixture, and so is the brass, an alloy of copper and zinc. So all these substances are mixtures. Having said that, we should also remember that all the mixtures are not same. There are different kinds of mixtures. As you can see, we have three glasses. Here we have a different kind of mixture, and these two are different from the first one. As we can see through our naked eyes, there is non-uniform distribution of particles in this particular glass. On the contrary, in these two glasses we have constituent particles mixed together in a way that they are not visible to the naked eye. As we discussed earlier, that in a mixture there is physical separation of particles possible in case of impure substances or mixtures, which is not the case with the pure substances. Also, we can see there are different phases or components of the mixture in this particular glass. This is muddy water, this is salt water, this is sugar and water solution. So these are three solutions: mud and water, salt and water, sugar and water. In the first case, the mud particles or the dust particles can be seen by the naked eye. There are two distinct phases. So this is a different kind of mixture. In the salt and water solution, we cannot have salt particles visible to the naked eye. Also, in case of sugar and water solution, the sugar particles are not distinct, they are not visible. So there is uniform distribution of particles in these two solutions. However, in case of this one, there is non-uniform distribution. The phases are visible or distinct. So this is an example of heterogeneous mixture, and this is an example of homogeneous mixture. So we have two types of mixtures, as we saw in the very first image, and homogeneous mixtures we have earlier discussed. So let us straight away come to the heterogeneous mixture. What are heterogeneous mixtures? Mixtures which do not have uniform composition. So this is very important. There is no uniform composition throughout the solution. These are heterogeneous mixtures. For example, mixture of soil and sand, sulfur and iron fillings, oil and water. We can have number of examples in our daily lives that can be attributed to heterogeneous mixtures. Similarly, we should remember that the boundaries of constituent particles of a heterogeneous mixture can be identified, as we earlier saw in case of mud and water. The mud particles could be easily seen, and there were two distinct phases. So these are some of the important points that have to be remembered, that there is no uniform composition throughout. The boundaries of constituent particles of a heterogeneous mixture can be identified easily, and there are two or more distinct phases. Example of heterogeneous mixtures that we can see in our daily lives can be many. We have salad, we have pizza, we have many other examples. What are the general properties of heterogeneous mixtures? Most of the mixtures are heterogeneous except solutions and alloys. Most of the substances, to begin with, we should remember, are impure substances or mixtures. And in case of heterogeneous mixtures, most of the mixtures are heterogeneous except solutions and alloys. We should remember that solutions are homogeneous mixtures and alloys are also homogeneous mixtures. So these two are exceptions. The components of heterogeneous mixtures can be identified easily, as we saw in various images, in various examples, that the components of heterogeneous mixture can be identified easily. For example, if we will form a mixture of oil and water, there will be two distinctive phases which can be even identified by naked eyes. Generally, two or more phases are present in a heterogeneous mixture. So there are two or more phases. We can have heterogeneous mixture of two substances. There can be even more than two substances present in a heterogeneous mixture. Particles of a heterogeneous mixture are sized between 1 nanometer and 1 micrometer or more. So to compare with homogeneous mixtures, the size of particles is bigger. Heterogeneous mixtures also show Tyndall effect. What is Tyndall effect? It is the scattering of light by the particles in a colloid. We will discuss Tyndall effect and Brownian moment in a separate video. Now, what are solutions? Mixture of two or more substances with one phase only. So there are no two distinct phases. Having no distinct boundary of constituent particles are known as solutions. So what are solutions? Solutions are nothing but homogeneous mixtures, because in case of homogeneous mixtures there is also only one phase. There are no distinct boundaries of constituent particles. Same is the case with the solution. Examples of solutions can be given as solution of sugar and salt, salt and water, soft drinks. All these substances are examples of solutions. It is a homogeneous mixture of two or more substances. As I earlier told you that solutions are homogeneous mixtures because there are no distinct boundaries, there are no constituent particles which are visible to the naked eye. So homogeneous mixtures are solutions. Components are mixed in such a way that they appear as only one phase. For example, if we prepare a solution of salt and water or sugar and water, we will not be able to identify the sugar particles or salt particles because they are mixed together in a way that they appear as a single phase or a single component. The size of particles is also extremely small as compared to heterogeneous mixtures. There are two types of components called solute and the solvent. There are two components in a solution. One of the component is known as solute and the other component is known as the solvent. In fact, the substance which is present in a smaller quantity is referred to as solute, whereas the component that is present in a larger quantity is known as the solvent. For example, in case of sugar and water, sugar is the solute and water is the solvent. So this is about some of the important properties of solutions that need to be kept in mind at this level. Now we will move on to discuss the types of solutions. We have also to discuss the colloids and suspensions, that will be dealt in a separate video. Thank you very much. Thank you for watching.